Hi everyone, and welcome to our Canva Extend web seminar on architecting for integrations. I'm Joel, and I'm joined by Timo, a fellow Canva engineer and co-owner of the Connect API. Together, we'll guide you through this session where we'll explore how to effectively use the Connect API to build sophisticated and lasting integrations. For today's agenda, we'll be covering 6 modules: getting started, auth and scopes, resources, asynchronous jobs, combining APIs, and our return navigation flow. We'll be building upon a comprehensive e-commerce demo project called Nourish, which is part of the Connect API Starter Kit. This project serves as an excellent example of how real-world applications can utilize the Connect API to enable powerful workflows. Each module will include a quick introduction, a code tutorial, and a working demo. This hands-on experience should give us a deeper understanding of the Connect API and REST API fundamentals. But first up, I'll hand it over to Timo to get us started.
Thanks, Joel. So first off, let's touch on what these APIs are. The Canva Connect APIs are a growing collection of APIs that allow you to integrate with Canva's design editor and collaboration tools. They're exposed as a REST API using JSON request and response bodies and the standard HTTP verbs and response codes. These APIs allow you to access and manipulate assets, designs, and other Canva resources from any platform. You can also perform workflows on designs like import, export, autofill, and more. Now, how do we get started? First, we'll go to canva.com/developers. Make sure you're logged into your Canva account. If you don't have an account yet, you can create one for free. To create a new integration, we can click on Your Integrations and create an integration. We can choose to create a public integration that will be available to all Canva users once approved and published. Or if we're on a Canva Enterprise plan, we can create a private integration for use only by members of our team. Today, we'll be creating a public integration. Agree to the terms. Please do actually read these when you get the chance, and create. We're now looking at the configuration for our new integration. Let's give it a name. This is what will be shown to Canva users when consenting to or managing our integration's connection to their account. We'll be using the Nourish e-commerce shop demo in the starter kit, so we'll call our integration Nourish. You can see we also have a client ID. This is the permanent OAuth ID for identifying our integration when we connect to Canva. Let's copy this, as we'll be needing it shortly. We'll leave the rest of the configuration for now, but as you can see, if we go back to Your Integrations, we can see our new integration here. We can also create additional integrations under the same account if we want. Now, let's get the Connect API starter kit set up. We'll head over to GitHub, where we have our starter kit publicly available. You'll need to clone this to your local machine. I already have a copy ready to go, so let's jump into it in VS Code. Let's find the e-commerce shop demo under Demos, e-commerce shop. We'll need to edit this .env file here. You can see our Canva client ID. We'll need to paste in the one we copied earlier. There we go. Joel is going to walk us through authentication next, so we'll leave the client secret for now, but I'll just point out one more thing first. The starter kit includes a pre-generated TypeScript client for all our APIs. You can find that under Client and TS. You're welcome to use that for your own integration, but we've also included our full OpenAPI specification. You can find that under OpenAPI as spec.yaml. Using this and a tool like OpenAPI Generator, you can generate a client library in whatever language you prefer. Okay, on to authentication now.
Before we're able to access a user's Canva resources, we'll need to take them through the OAuth 2 authorization flow. In order to complete a user authorization flow, we'll first need to authenticate the client with client credentials. We already have our client ID, but now we'll need to generate a secure client secret which we can use to authenticate the client from our app. The client secret is highly confidential, and so it can only be copied from the developer portal right after creation. Now we'll need to securely store the client secret somewhere in our app. Because the client secret is a confidential value, it needs to be stored somewhere that doesn't risk becoming publicly exposed. Rather than placing it directly in our source code, let's place it in our environment file with the rest of our config. This file is included in our project's gitignore registry, meaning it won't be added to hosted version control where it could become exposed. Canva has its own secret scanning services that can detect and revoke exposed tokens, but please don't rely on that and always practice good secret management. The next step in our integration setup involves selecting our allowed scopes. These are a set of all possible scopes that we might ask the users for when they connect to our app. Since scopes provide third-party access to user data, it's important that we only request the scopes that we need to make the app functional. Lastly, in the dev portal, we'll need to specify a redirect URL that we should navigate to after the user presses accept. Since we're running our app locally, we can just provide our localhost address. Now that we've finished our dev portal setup, we can begin to construct our authorization URL. The authorization URL is a Canva endpoint which displays the Canva OAuth consent page. To build it, we'll start by heading to the demo backend, opening our auth service, and making a new getAuthorizationURL method. We'll start with our base Canva Connect URL, and then we'll attach the route, which is OAuth/authorize. We'll need a few query parameters to construct this link, the client ID, which we can retrieve from our environment config, a list of scopes that we want to request. These should be a subset of the allowed scopes that we configured in the dev portal earlier. We'll need a redirect URI that we want to navigate back to after the user presses consent, the response type, which is set to code, and lastly, we'll need to supply something known as the code challenge. Now, you might be wondering what that is. Modern OAuth flows utilize a security method known as PKCE, or Proof Key for Code Exchange. It involves generating a cryptographic key-value pair which we supply at the beginning and end of the authorization flow. This helps us to complete the entire flow without it being intercepted by unwanted guests. We'll start by going to our backend routes, opening the auth file, and implementing the authorize route. Now we'll generate the pair using the crypto library. The code challenge is passed into the auth link, and we'll store the code verifier as a cookie for us to retrieve later. Once we have our authorization code, we can complete the second part of the user auth flow, exchanging the code for an access token. From our backend, we want to perform the exchange access token operation. In the same auth file, let's create a redirect route handler. We'll start by creating a basic auth client, which will supply our client credentials. Let's quickly jump over to our client service file in the common library and make a method called getBasicAuthClient. We'll do this by taking our client ID and secret pair, base64 encoding it, and then setting it as our basic authorization header. Going back to our route, once we have our client ready, we can set our parameters for the request. We'll need the grant type, which we set to authorization code, the code verifier, which we retrieve from our cookie, the auth code, which we pull from our query parameters, and our redirect URI, which should match the one we previously used. Assuming that all worked correctly, we retrieve the token, decode it using the Jose library, pull out the user ID, and store it in our local database. Let's do a quick run through by clicking on the Connect demo, which opens the Canva consent page. There, we should see the name of our app and a list of our requested scopes. And once we click Allow, it takes us to our callback where it stores the access token ready for us to use.
Now that we're authenticated, what can we actually do? Let's briefly go through the core Canva resources that make up the Connect APIs. All of these can be found at the top level of our REST API. There are, of course, your actual Canva designs. There are your assets, such as images that you want to edit or use in your designs. There are folders for keeping your other resources organized. And additionally, if you're using a Teams or enterprise account, there are the brand templates for your team. For the most part, these resources support the expected CRUD operations using standard HTTP verbs. So post to create a resource, get to list or retrieve a resource, patch to update one, and delete to delete a resource. For an example, we can jump back into the starter kit in VS Code. Let's find the generated client library. So that's under Client TS Services. And if we look at folder service, we can see examples of all of these that I just mentioned. So you can see here we have a post operation to create a new folder, a get operation to get a folder's metadata, another get under the item sub-resource to list folder items, a patch to update a folder metadata, and delete to delete a folder. So far, all of the operations we've mentioned are synchronous. That means when you get a success response, you can assume the operation is complete. However, some of our operations are necessarily asynchronous. These are operations that have the potential to take significantly more time than an HTTP request can usually be expected to respond in. Our asynchronous operations are uploading an asset, importing a design, exporting a design, and performing a design autofill, where data is mapped into a brand template to generate a new design. For large designs, these operations could take multiple seconds or, in the extreme, even minutes to complete. Holding a synchronous connection open for that long would be inefficient for both the client and server. As such, these operations are modeled using a trigger and poll approach. Let's jump into the Nourish e-commerce shop demo code to see what this looks like. The demo includes a function to upload a product image to Canva as an image asset. You can see here, we post the image data to Canva in one operation, and this gives us back a new asset upload job. We then poll the job for successful completion. Let's have a deeper look into the polling logic. You can see the actual operation we're doing is just a GET request for the asset upload job, but it's wrapped in this additional poll function. I want to highlight some key parts of this poll function. First, we start with a reasonably small initial delay between retries of the polling operation. This will provide an immediate result for end users, in the case where async job completes quickly. Next, we have an exponential backoff factor to repeatedly multiply our delay by on each retry. This ensures we ease off on the frequency of our poll requests to avoid any chances of our requests being throttled. Finally, we have a max delay. This ensures we don't back off our retry attempts to an unreasonably long delay, in the case where an async job takes a substantial amount of time to complete. I'd also recommend having a hard timeout on the entire poll loop to avoid polling forever, in the unlikely case a job gets stuck in progress and never completes. One additional thing I'd like to point out with async jobs is that you can trigger and poll multiple jobs in parallel. If we jump over to another part of the e-commerce shop demo code, we can see an example of this. The demo includes a feature where you can generate multiple design variations for a product promotion all at once using design autofill. This code triggers all of the autofill jobs in parallel and then waits for successful polling results for all of them before continuing. We'll demo some of this in a bit, but first I'll pass it back to Joel for a few more key concepts.
Now that we've had an overview of our API, let's start putting it all together. The Canva Connect API, like all REST APIs, is built to be modular and flexible. Its true strength lies in the ability to chain multiple requests together, creating dynamic workflows that can elevate your platform. In REST APIs, it's important to consider not just the resources we're working with, but also the relationships between resources and how they can reference and interact with one another. For example, we can use our folder API to list items within a folder. Possible items contained in a folder include assets, designs, brand templates, and even additional folders. In order to maintain an efficient API, we've introduced the concept of a summary object. A summary object is the same as a full resource object, except it has several key fields omitted. These are fields that generally reference deeply nested resources that can typically lead to inefficient data overfetching. To put it another way, summary objects are ideal for situations where we only need to display a preview of a resource, such as listing the names and thumbnails of items in a folder. When we need more detailed information, typically we display it on a separate page or modal, calling the API to retrieve the full object using its ID. In addition to using nested resources to render our responses, we can also use object references as inputs for the creation of other resources. For example, we can upload an image to a user's account, and once that's completed, we can use the ID of that uploaded asset to create a new pre-filled design. Let's take a quick look at our demo. On the marketing page, we want the ability to take one of our products and create a new Canva design. Jumping into the code, let's start by navigating to our demo front end, opening up the single design generator page, and adding an onCreate method. First, we'll ensure a product is selected, and we'll add a loading state for the async operation. We'll make a method called uploadAsset and createDesignFromProduct, which takes the selected product. We'll implement this method in our front-end design service file and start by grabbing the name of the product. Then we'll upload the asset using the async approach that Timo went over. Assuming the upload completed successfully, we can retrieve the uploaded asset, which should contain a unique asset ID. Let's take this ID and the product name and pass them in as arguments into our createDesign operation. And finally, if there are no errors, we can return the newly created design to our onCreate method, add a success alert, and add some confetti. Going back to our demo, we can now create a new campaign, select a product, and click Create Design in Canva. And after a bit of loading and some confetti, we have our newly created design, which is pre-filled with our uploaded asset. Now that we have an actual Canva design, up next, we'll take a look at how to incorporate design editing into our integration. Editing designs is a key part of any Canva workflow, and so naturally we want to offer a way for third-party apps to connect their workflows with the design editor, enabling a fully integrated user experience. This is where the return navigation architecture becomes useful. It provides developers with a way to configure and inject their own return navigation directly into the Canva editor, allowing users to return to the third-party platform and close the loop on integrated workflows. To begin our implementation of this workflow, we first need to go to the return navigation section of the developer portal and enable the feature. Once this has been enabled, we can then specify our return URL. This is the entry point that we'll use when redirecting from Canva back into the integration. For the first part of our implementation, we want to construct a link that takes us to the editor page for a specific design. A sensible place to put this is the product page, where we can introduce an Edit in Canva link. Let's start by navigating to the demo front-end pages and open the products file. We'll create a handler method to consume the button click, then we'll create a function that builds our special return URL. We'll pass in the standard edit URL, and next we'll pass in some state to tell the integration what page we're coming from and what product we clicked. Once the link is constructed, we can open it in the browser. Next, we'll navigate to our front-end services and open the Canva return file. Let's create a new method called createNavigateToCanvaURL, which takes the arguments from our newly created design and builds us a dynamic edit link. There are several steps to preparing the correlation state. First, we stringify the object into a JSON string, base64 encode it, and then URL encode it. Once we have our encoded state, we append it to the search parameters, and that gives us our constructed link. Now that we've implemented our link construction, we can run a quick test by going to the products page. Let's go to one of our products and click on Edit. This takes us into the Canva editor with our newly created design ready to edit. You've probably noticed one key difference with this editing experience is the inclusion of a dedicated Return to Integration button. Once the users finish editing the design, they're prompted to click on the Return button, which takes them back to the integration. Our return page doesn't do much at the moment, so let's make it perform an export and return to the original page. We'll start by going to our demo backend routes and opening the return navigation file. This is where we'll implement the return handler. Because this is a single entry point which consumes all return redirects, we'll need to decode the correlation state to handle the request. In our backend redirect route, we first want to retrieve our correlation JWT parameter. To make this flow secure, we've encrypted the entire state in a token which we can decode and verify using Canva's public key. To do that, we'll simply target our public keys URL located at api.canva.com. Next, we'll pass it into the Jose crypto library to build our JWK set. Then we'll verify the supplied token, ensuring we've set the current client as the token audience. The existence of our protected header can tell us whether the token is legitimate. Once we know that our token is verified, we can use the same Jose library to decode our token and pull out the design ID and correlation state. Finally, we can serve up the front-end return page where we attach our design ID and correlation state ready to be processed. Jumping into the front end, let's go to our pages, open the return navigation file, and create a method called fetch and export updated design that runs on page load. We grab the design ID and correlation state string from our parameters, and then we perform the reverse operation that we performed earlier, first decoding the base64 string, and then passing the JSON string into our state object. Let's use the design ID to fetch and export the design, print out a nice success message, and finally, we use the correlation state to redirect back to the original page. Let's quickly run the demo again, first clicking on our design, which takes us to the editor page. I'll edit the design a bit to change it up. And once we click return, it takes us back to the demo app, which processes the token, and takes us back to the original page where we can perform further actions.
That was so slick. I hope this has given you an idea of what you can build using the Canva Connect APIs. To recap, check out canva.com/developers. Read our API docs and developer guides. Clone the starter kit and have a play for yourself. You can also join our developers community at community.canva.dev. We can't wait to see all the fantastic integrations you build on our APIs. Thank you, and have an awesome day.